Hello and welcome to the Algebra 1 videos, and this is Unit 6, and this is a section over nonlinear functions. So these are functions whose graphs are not lines. So these are graphs, so these are not lines. Okay, they can be parts of lines or curves. Okay, and we're going to talk about that today. So it's going to be pretty interesting stuff, some new stuff for you. But what I want to talk about today in section 1 is linear piecewise defined functions, okay? And here are your objectives that you can read. But when I want to talk about a piecewise functions, these are pieces of the graph, pieces of different graphs on the same graph. So pieces of different graphs on the same graph, okay? And so what we'll do is we'll kind of look at an example on, how we would talk about that. So the first thing I want to do is talking about this thing where it says graphing restricted domains. Remember, domains represent x values. So these are x values, okay? And it says that Lena walked for a half hour at an average speed of 4 miles per hour to the library, which is 2 miles away. She stayed at the library for 2 hours, and then she walked home at an average speed of 3 miles per hour. Graph Lena's trip. So what I notice is that my x values are hours, my y values is distance from home. Now what I know about this is that if I take the slope, the change in y divided by the change in x, which is my slope, okay, that's going to give me the change in y. My y was a measure of distance. So this is distance from home, and I'm sure that's in miles, divided by my x value, which is number of hours, so miles per hour. Okay, so when they talk about, 4 miles per hour, walking to the library, and then 3 miles per hour walking away from the library, that's talking about the slope, okay? So that's where those numbers come in. So what I know is that Lena walked for a half hour at an average speed of 4 miles per hour, okay? And so what we get is that if you walk for a half hour at 4 miles per hour, then, here's what we've got. If I were to graph, say, 4 miles per 1 hour, my rise here is 4, and my run is 1, okay? But that's something that, we need to kind of talk about because we only do this for a half hour, okay? So what I'm going to do is I'm going to come in, I'm going to graph this, and I'm going to come in here and say that we did this for a half hour. And so we know that the library is 2 miles away, okay? And so the distance that she traveled in that first half hour is 2 miles, okay, if you're traveling at 4 miles an hour, okay? And so the black graph is the graph that I'm using for my function. The red is just to kind of tell us, what we're doing. Then the other thing is that, she stayed at the library for 2 hours. Okay, so this is 0.5, so if you stay there for 2 hours, then you would stay there until 2.5 hours. So but you didn't go anywhere. She didn't go anywhere. So the distance that she is from home doesn't change, and that goes all the way to here. Okay, and then she walked home at an average speed of 3 miles per hour. So when I graph that, okay, I'm going to graph 3 miles an hour. That means that we're going to go down 3 and then over 1, okay, and connect those 2 points like this. All right, but I need to color that in. I just wanted to get my slope in there to draw that in there. So my black graph is the one that's in there that tells me. So she was gone for a little bit more than 3 hours, 3 hours and change. But it's, this is the graph that represents. The black graph represents of her walking away to the to the library, staying at the library, and then walking home. Okay, this is a little bit steeper than this one, So she was walking faster going to the library than she was returning home, okay? So then if I wanted to analyze this piecewise function here, okay, what I want to do is I want to write a function definition for this graph. I want to actually write an equation, okay? So what I want to do, the first thing I want to do is let me come in here and let me write the equations for each of these lines. Okay, this equation here has a y-intercept of 3, so b is equal to 3, and then the slope, I go from up here over, so that's going to be 2 over 5, so my slope is going to be positive 2/5, okay? So this equation here, all right, for this graph, I'm going to color that in red, this equation is going to be y equals 2/5 x plus 3, okay? And we need to be able to write the equations of lines, guys. That's pretty important, all right? The next thing that we have is this line over here, okay? And this line, we notice, has an open circle here, and it continues in this direction, okay? The y-intercept here, b, is equal to 1, okay? But my slope goes down 2 over 3, so my slope is equal to negative 2/3. So my equation for here is y is equal to negative 2/3 x plus 1. All right. Now, if I wanted to combine these, because the difference is that my graph for the red graph exists when the values are less than 0, and the values less than or equal to 0. My blue graph exists when my values are just greater than 0. So what I'm going to do here is I'm going to call this function f of x, okay, the whole thing, it's all one function, but there are different pieces to it. And so I make this little bracket sign here, and then for the red graph, I'm going to write that was 2/5 x plus 3, and that exists when x was less than or equal to 0, okay? So this is my domain, okay? This graph exists only when the x values are greater than or less than or equal to 0, okay? Now the other one, okay, was negative 2/3 x plus 1, and that only existed when x was greater than 0, okay? So, that's how I write these graphs, okay? Here's the graph, here's the equation, and here is where it exists, okay, for the red graph. Here's the blue graph, here's the equation for that, but here's the domain at where it exists. It's greater than 0, okay? So we want to know of the whole function of this whole graph, what's the domain of this entire function? So, we have negative x values and 0, and we have positive x values and 0. So the domain of this function is all real numbers, okay? For every x value, we have a y value. Now, the range is a little bit different. The range only goes, I have all these y values here, but they only max out at positive 3. So what I know is that the y values only exist when they are less than or equal to positive 3. So I know that y is less than or equal to positive 3, and that's the range of my function. And all I'm doing is just looking at the graph and reading it, okay? And that's it. Okay, what I know here, okay, let's evaluate a piecewise function graphically. So what I want to do is I remember this notation, okay? What this is saying when I find f of, say, negative 2, this is asking the question, what's the y value when x is negative 2? So what's the y value when x equals negative 2? Okay, that's the question. Same thing here, what's the y value when x is 0? What's the y value when x is 5? So, but we have different graphs over here. Okay, we have this horizontal line here for negative x values. When x is 0, we have a value of 3. And then we have this line when x is positive. Okay, so if I'm finding f of negative 2, okay, I'm finding negative 2 here on my x, and then I'm finding the corresponding y value, which is right here at 2. So f of negative 2 has a y value of positive 2, okay? And then if I were to find f of 0, okay, go over here to 0, and then what's the y value? Now, I have holes here, but I have an actual point here. So here at 3, I have a point. So f of 0 is equal to 3. And then let's look at f of 5. Okay, 5 is here on the x. Down here, find the corresponding y value and plot a point. So when x is 5, y is equal to negative 2. So we get a value of negative 2. Okay, so this point over here is the point negative 2, 2. Okay, and that's what this notation means. Okay, it means that this is the point negative 2, comma 2. All right, the next one here, this point is the point 0, 3. Okay, and that corresponds at this point here. Okay, if I were to rewrite this in a coordinate point, I would write it as the point 0, comma 3. And then this point down here is the point 5, negative 2. Okay, and then, you know, if I were to take that point, it's, you know, this notation, it translates to the point 5, negative 2, and that's it. Okay, so there's that. Okay, so there's that page. Hope that makes a little bit of sense to you. I know it's kind of weird and difficult, but, you know, similar stuff that we've been doing. Okay, next page. Okay, on this page, what I have is an actual piecewise function here, okay? And we'll work on how to graph these on the calculator in class, but I'm not going to do it on the video. But what I want to do is I want to take this function and I want to find these values. I want to evaluate f of negative 4, f of 0, and then f of 7/3. Okay, so what I want to do is take a look at this and say, all right, so if I were to find f of negative 4, so, you know, again, the question is, you know, what's the y value when x equals negative 4, okay? So what I have to do is I have to come over here and I have to say, okay, well, which one do I use? Which equation do I plug negative 4 into? But I have to consider my domains. And I have to say, okay, negative 4, is that going to be less than negative 4? And the answer to that question is no. Negative 4 is not less than negative 4. But negative 4 is less than or equal to negative 4. So what I would need to do is plug negative 4 into this function and evaluate that for y. Okay, so I'm going to plug f of negative 4. In this case, let me do some work over here, sorry. If I were to find f of negative 4, okay, then because negative 4 is in this domain, I would plug that number into this function. So I'm going to do negative 2 times negative 4 and then plus 3/5. Okay, so let me zoom in on that. Let me evaluate that over here. This is going to give me positive 8 plus 3/5. And this is 8 over 1. We need to add fractions, so we need a common denominator of 5 and 5. Multiply that up top and bottom. And so that's going to give me 40/5 plus 3/5. And that's going to give me 43/5. Okay? And that's my answer. Okay? That's the y value that we have. So what I know is that f of negative 4 is equal to 43/5. Okay? And that's it. That's all I'm trying to find. Okay, now on the next one, f of 0, okay, again, what's the y value when x is 0? Okay, so plug 0 into one of these functions, but where does that exist in our domain? So, you know, is 0 less than negative 4? And the answer to that is no. Is 0 in between negative 4 and 2? And the answer to that question is yes. So what I would do is I'd plug in 0 into this function here, and that's going to give me negative 2 times 0 plus 3/5. And negative 2 times 0 is just going to give me 0. So we just get the value of 3/5. Okay, and that's what f of 0 is equal to. Okay, if I were to find f of 7/3, you know, 7/3 as a decimal, if you took 7 and divided it by 3, so 7/3, that would give you 2.3 repeating. okay? So 2.3 repeating is a number that is larger than 2. So I'm going to plug 7/3 into this function here. So that's going to give me 4/3 minus 7/3. So this is going to give me 4/3 minus 7/3. And then 4 minus 7 is going to give me -3. And then divided by 3, and that's going to give me -1. Okay, and that's all we're doing. So it's kind of tricky. You know, it's not that hard, but you have to think about your domain and what values they fall into. So depending on what your x value is, you'd have 3 different options to plug it into. Okay. All right, so let's take a look at something here. Let's go ahead and graph this piecewise function. And I'm going to use a table to help me out with this one. And so let's kind of zoom in here and let's kind of evaluate this. So we have this piecewise function here, okay? And this is the function 3, and that's defined for when x is less than -2.5, okay? And so what I want to do is look at this and say, okay, well, if I were to plug in any x value into this function, I would get a y value of 3. Okay, this is a horizontal line at 3. So if I were to plug in -5 into this function, okay, -5 is less than -2.5, and it would give me a y value of 3. So I'm just going to plug in 3 here. Now, if I plugged in -2.5 into this function, it wouldn't exist because -2.5 is not part of our domain, okay? We are talking about values that are strictly less than -2.5. So this is going to be undefined. Okay, UND. All right. Now, if I were to plug in, say, -2.5 into my second piece, because these x values are between -2.5 and +4. So if I were to plug in -2.5 into this, okay, let's see what we get. If I took -2.5 and then -3.7, what's that going to give me? That's going to give me +2.5 minus 3.7, and that's going to give me a value of -1.2. Okay, so my y value here would be -1.2. All right, now if I plug in 0 into this function, okay, I get -0 minus 3.7. That's just going to give me -3.7. Okay. And then if I have a value of 4, plug in 4 into that, it's going to give me -4 minus 3.7. So let me do that. That's -4, what's that? -7.7? Okay. So that's -7.7. Okay. Then all of a sudden we change graphs, okay, and we have piece 3. Now, if we want to plug in 4 into that third function, we can't do that because it's not in our domain. Okay, 4 is not greater than 4. That's a false statement. So this is also undefined. Okay, now I could plug in 5. That would work. Okay, so if I did 4.2, so 4.2 plus 1.1 times 5. Okay, that's going to give me 4.2 plus 5.5. All right, and 4.2 plus 5.5 is going to give me 9.7. Okay, and so that's what we've got, so 9.7. So, you know, let's go ahead and just graph these over here. And it's kind of tricky to do this. And so let's do this. Let's graph my piece 2, because that's an easy one to graph. So let's plot those points of -2.5 and then 1.2. And let me do that part in red. So -2.5 and 1.2, -1.2 is right about here. Okay. 0 and -3.7 is right about here. And then 4 and then 7.7 is right about here. Okay, so now in between -2.5 and 4, I have this graph. Okay, I don't extend it any further than that because I'm just talking about between -2.5 and +4. Okay, now The other issue with this is that we have the value of -5, or of 3, okay, this function here. So this function is really easy to graph because it's just a horizontal line at 3. But it exists in between, or values that are less than -2.5. So what I'm going to do is I'm going to come over here, and I'm going to draw the line of -3 for values until we get to -2.5, and then I have a hole here. Okay, remember how we were undefined at 2.5 or at -2.5? That's what gives me my hole, okay? So now, all right, so I'm going to come in here, draw that. Let me put actual endpoints on this, okay? And then we have that last function where we have 4.2 plus 1.1x, okay? Now what we have is we have the value, when 5, we get 9.7, okay? So I'm going to come over here. I know that point exists at 5, comma 9.7. So this is, hold on a second, 2, 4, 6, 8, 10. So it's going to be somewhere over here, okay? It doesn't have to be perfect, but it's going to be up over here, all right? And we have this point here, and we have a slope of like 1.1. So it's going to go down like this, roughly, to 4. And, hold on. That's wrong. Not that point. This point. Okay, hold on. This point, right here. Okay, that's that point. 5, 9.7. 5 is in between. This is a value of 6, so it goes 2, 4, 6, 8, so 5 is in the middle. So 5, 9.7 is right here. Okay, now we have a slope of 1.1 on this graph, so I know to just kind of plot it going this way. Okay, now I have to leave an open circle here, all right, but I'm going to have my arrows pointing that way. Okay, so that's the graph. That's it, okay? I know it's kind of tedious and kind of weird. We will work on how to graph these on a calculator on Desmos, so it should make a little bit more sense. So I hope you enjoyed this video, and we'll see you soon. Thanks. Bye.